Hi, welcome. So this is for our science. This is for week 28, might be week 27. I've lost track. This is the fourth science video that we've done for home. So sorry, I can't remember the week right now. Kind of funny. But I'm just going to go ahead and share with you guys. First of all, just if you want to do the activities that are on this science lesson, then you can just go ahead and use the list that we give you that we link to you. I'm also going to share it with you right now, right here. And so the list right here has these things. So these three are printouts, and the printouts are get to know your oops, that one. So inventing a heat engine is one of them. One of them is a heat spinner. You only need one of these squares to make one. So you can just print that once for however many people you want in your household and get to know your spinner. And then this is going to be the mystery we're going to watch. But also you'll need, if you want to do the activities that are in the mystery science, we've got a ruler, scissors. You'll need a pencil with a good eraser, so one that doesn't look like this. It needs to have an eraser on it because you're going to need it. An 8-ounce paper cup, a pipe cleaner, a push pin, 2 rubber bands. That says 1 rubber band, but you need 2 rubber bands to reach around the paper cup. Then to make it work, you'll need a desk lamp with a 40-watt incandescent bulb. I know if you have a Scentsy warmer, that would work really well. A mug of hot water. You could also use one of those rice bags and put it in your microwave, just something that will emit heat out of it, but not necessarily steam. So your mug of hot water, you don't want to get it all wet. For the other experiment at the end of this, there's going to be a penny experiment, penny popper experiment. And for that, you would want a bucket or a large bowl and some icy water, like it will be full of ice water. You'll want a small glass bottle, like a soda pop bottle, that you make sure the penny can cover the entire opening. And then you'll need a wet penny. If you don't have a glass bottle, you can try a plastic bottle. I didn't try it with that. I think plastic probably doesn't conduct the heat as quickly, so it may not work as fast, but it might eventually. You could certainly try it. Although I think that plastic is more of an insulator than it is a conductor, and you want it to conduct heat, so you might want to just use a glass. The other thing that you will want to do is you'll get a link to read the history of the steam engine, and this is just a fun bonus thing that you can do. And that link is on Ducksters. It's right here. And so you can definitely read that. It's really fun to read about the steam engine. And then also there are 2 really cool videos that I will link you to. They're not going to be on this video, but they will be links that you can look at. One is how a steam engine works. It's a really good video. It's really interesting how the steam engine works. And the other one is a steam locomotive. You can watch how I'll show a little bit of it to you. You can watch how the steam locomotive works. You're actually sitting in the engine watching. Pretty cool. All right, so let's go ahead and we're going to do our mystery science first. Mystery science is how long did it take to travel across the country before cars and planes? So I'm going to go ahead and bow out of this.
Hi, it's Doug. Imagine if you lived your whole life without ever leaving your town. If you live in the mountains, you never see the ocean. If you live by the ocean, you'll never see the mountains. Imagine the country where you live is the only country you'll ever visit. That would mean, unless you're within walking distance, you'll never get to see things like the Hollywood sign or Disney World or a sunset at the Grand Canyon. You'll never get to visit the Eiffel Tower in France or the Great Wall of China. You'll never see the Great Barrier Reef of Australia. It's kind of sad to think of never having a chance to see any of these things, right? But if you lived in pretty much any other time in history, that's what it would have been like. Long distance travel just wasn't possible. People were pretty much stuck wherever they were born. If they did travel, the journeys were slow, uncomfortable, and sometimes even dangerous. Luckily, travel today is easier and cheaper than ever. It's so easy, we often take it for granted. But stop and think about it. What's one distant place that you'd like to visit in your lifetime? How would you travel there?
Okay, so I know that one place that I would really like to go to is Peru and to Machu Picchu. And I know because my daughter went there that you have to fly to a city, Lima, Peru, and then you have to take, you can either rent a car or take a bus up into the mountains, and then you have to hike part way and then hike the rest of the way part way. And that is how what I would want to do. So what would you want to do? Where would you want to visit and how would you travel there?
A long time ago, if you wanted to go somewhere, you had to get there by foot. Like, imagine you wanted to travel across an entire continent, like from one side of North America to the other. On foot, that would take you about 6 to 8 months. A journey like that took such a long time and was so dangerous and difficult that it wasn't really a trip that most people took. Before long, though, people realized there's a better idea. Why not hitch a ride on an animal instead? That's a big improvement. Riding a horse, for example, doesn't require nearly as much of your energy as walking does. Plus, you could hook up a cart or a wagon to carry things with you or move several people at a time. Now, on a horse, people could go from one side of the continent to the other in only about 3 to 5 months. That's definitely a lot better than 6 to 8 months. But it's still such a long time. There were also new challenges that came along with having animals to carry you or pull a wagon for you. Now you had to care for them, bringing them to fresh water and letting them rest. Plus, you had to get food to feed them, like oats or hay, plants that had to be grown. It took a lot of work planting those crops and then harvesting them. And that's not even food people got to eat. That was just the food for the horses. Surely there must be some better way to get around, people thought. In fact, you know that there's a better way. Things we use for travel today, like airplanes and cars and trains. But these weren't invented until the 1800s and the 1900s. Each one is incredibly complex, made of many different parts working together. These machines weren't just thought up overnight. It took many years to develop them into what we know today. But it still seems like a big jump. How did we go from having to travel everywhere on foot to riding animals to then having amazing machines like cars and trains and airplanes? It turns out the first clue was actually discovered more than 2,000 years ago. An ancient Greek inventor named Hero came up with a toy, a little device like this. You could take off the top and fill it with water. Then you can heat it over a flame. What do you think will happen? Watch. Let's see that again. When the water begins to boil inside, it becomes steam, which builds up inside the container. Then the steam shoots out of the openings on the sides of the container. Since the openings are angled a little bit, the container starts to turn and spin. No one, not even Hero himself, thought about using this device to make it easier for people to get around. For Hero, it was just something fun to play with and show off to friends at parties. But does it have potential to help people get around? How could this be useful to people? What do you think?
Okay, so what do you think? How could this device be useful? So you notice it spins. What if it weren't made out of glass, but it were made out of metal and it was a lot larger and it could actually have things attached to either side of that thing? Something to think about. Steam moving things.
In today's activity, you're going to make a machine that uses heat to make a spinner spin. In the first part of the activity, you'll make a spinner and a spinning support tower. In the second part of the activity, we challenge you to use heat to make your spinner spin steadily. To do that, you're going to have to think like an inventor. Inventors experiment and pay attention to what happens. And just as important, they pay attention to times when nothing happens. Sometimes the only way to figure out why something works is to see where it doesn't work. I'll show you how to get started experimenting step by step. Find a partner. If you're working alone, that's okay too. When you're done with this step, click the arrow on the right. If you're working with a partner, decide who will be the twister and who will be the spin master. Get these supplies.
So these are the same supplies that I told you about at the beginning. So the copies you'll need and the different supplies if you're going to do this.
You'll start by making the spinner. Each person cut out one spinner. Set aside the extra one. You may need it later. Flip the square over so that you're looking at the white side. You're going to fold on both diagonals like this. To do this, line up the ruler on the corners and fold the paper on the ruler like this. Then take away the ruler and crease the fold with your fingernail. Unfold it and fold along the other diagonal too. Unfold the square and flip it over so that the printed side is up. Now you're going to fold it in half both ways, side to side and up and down. Do it like this. Use your ruler to fold it. Then, crease the fold with your fingernail. Unfold and fold the other way. When you're done, it should look like this. Flip the square over so that you're looking at the blank side. Find where all of the fold lines intersect and draw a dot on that spot. Now that you've folded your square, you should be able to gently push the sides together so that it looks like this. Once you do that, cut out the 4 gray shapes. When you're done, your spinner shouldn't be flat. It should stick up a little in the center, like a mountain. Now it's time to make a support tower for your spinner. Spin Master, use a pen or a pencil to poke a hole in the bottom of your paper cup like this. Then, widen the hole with your fingers as big as you can. Spin Master, hold the cup with the bottom side up. Twister, put 2 rubber bands around the cup like this, one around the bottom and one around the top. If you're working alone, get help if you need it. Twister, fold the pipe cleaner in half around the push pin. Then, hold the pipe cleaner like this and twist the pencil like this. Twist until the pipe cleaner holds the push pin tight. Then, take the pin off the pencil. Spin Master. Pull the rubber bands away from the cup like this. And Twister. Slide the pipe cleaner in between the rubber bands and the cup like this. The rubber bands will hold the pipe cleaner in place. Twister. Bend the pipe cleaner so that the push pin points straight up over the middle of the cup. It might take you a few tries to get it straight. It will look like this when you're done. Spin Master. Set one of the spinners on the point of the push pin. Give it a gentle push. Does it spin easily? If not, you can use the engineering checklist to fix it.
Okay, so if it doesn't do it, it's the spinner drag is against the pipe cleaner, adjust it, or make sure that the pin points up, or make sure that the spinner is set on the pin right on the dot you drew. Look from below to check. And if none of these things help, then try the other spinner. Okay.
Before we do some experiments with heat, you're going to get to know your spinner. Working with your partner, try the experiments under number 1 and number 2 on your worksheet. Be sure to write down what you notice.
Okay, so working with your partner, set the cup on the desk and try these experiments and write down what happens. Does the spinner wobble? Does it spin? Does it do nothing at all? Try breathing gently on your spinner from one side. What happens? Try blowing gently down on your spinner from straight above. What happens? Talk to your spinner. La la la. See what happens. Fan the spinner with your hand. What happens? Now you're going to try to pick up the cup very carefully. It takes skill to pick up the cup without knocking off the spinner. Once you can do that, try these experiments. Lift the cup straight up high, what happens? Lower the cup straight down, what happens? Have your partner hold the cup while you blow upwards and into the cup. Says this is tricky, what happens?
Discuss. Then watch the next video.
So after you did those things, what pushed on the spinner to make it spin? And do you have any ideas about how heat could make the spinner work or move?
In case it's helpful, here are some things we noticed. You can make the spinner move by blowing on it, by fanning it, or even by talking at it. You might find out that some words even make it spin more than others. The spinner moves because talking, blowing, and fanning all make air move. That moving air is what pushes on the spinner and makes it spin. When I pick up the cup, I do have to move it slowly to keep the spinner balanced on the pin. But once I get the hang of it, I can make the spinner move by lifting it up or by lowering it. By moving the spinner through the air, I made the air push on the spinner, and that made the spinner move. Did you notice that the spinner turned in one direction when I lifted it up, but then turned in the other direction when I lowered it? The direction of spin depends on which way the air is moving. Now, you're going to try using heat to make your spinner move. As you experiment with heat, be sure to move slowly and cover or shield your nose while you're breathing or talking. A sudden movement or breath of air can change your results.
Okay. Moving air makes the spinner move. Does that give you any ideas about how heat could make the spinner move? Okay, so let's go on. So since we have time, go ahead and go to the next one. Here we go.
If you're in a class, form a group of 4. Your teacher has set up an experiment station. Groups will take turns experimenting at the station and discussing and inventing at your desks. Later, when you're at the experiment station, your goal will be to use heat to get the spinner to spin 30 times. Now, to make it easy to count the spins, we've marked one blade of the spinner with a star. To count the spins, just count how many times you see the star go around, like this. 1, 2, 3. Now you try it.
1, 2, 3, 4, 5.
Now that you've practiced, go to the next step. Get your supplies.
Okay, so you'll need this sheet that you should have printed off called Inventing a Heat Engine. I'm just going to show it to you really quick. So inventing a heat engine. So you watch the video on the screen with the spinner and the candles and discuss what would be making that spinner move. Draw a picture to show what you think is going on. How could you use a paper heat spinner in a chain reaction machine? Draw a picture, describe what you could do. Now I'll let you guys pause the video, of course, to do what you need to do with these. I'm just reading them to you, but if you have the sheet, then you'll know. Otherwise, you can read it right here and just pause my video and read it and then go on. Number 3 is talk to your spinner, figure out what sentence makes it spin the most, and discuss the spinner spins in one direction when you lift the tower and other direction when you lower it. So explain why that might be and draw a picture to support your explanation. Okay, so you're going to have something hot. Remember I talked about that before. It's going to be either a hot light bulb, it's got to be an incandescent light, just meaning a regular light bulb that gets warm. Those Scentsy warmer lights are a really good thing that you could use. You can use a heat, like I said, a rice bag and heat it up, or you could use like a steaming hot. You could use a candle only if your parents are there to help you, because obviously we can't have fire at school, so that was never mentioned. You can have a candle at your house, but just remember to do it with your parent and don't do this on your own with any kind of open flame. And of course, you don't want to get it too close either because you're going to be using paper next to it. So have your parents help you if you're going to do that. Okay, going back to our video.
If you're in a class, your teacher has set up some experiment stations with a heat source. Your teacher will decide what order you'll go to a station. When your group is not at a station, you'll be working at your desks, discussing and inventing on paper. If you're working alone, you can decide what to do first. Okay, it's time to do your worksheet and experiments. Start with the discuss and invent questions 1 through 4 at your desk. Or do question 5 if it's your turn at the station. A video for question number 1 is on the next slide. When you're doing question 1 on your worksheet, watch this. When everyone's done with the activity, be sure to go to the final video.
Okay, so just because that's really fun, I just want to show you guys something. So when I was in Munich, Germany, Germany is famous for these beautiful, their nativities. Let's see if I can get it where you can see it. Here we go. And these nativities are designed to do that same thing. So I thought I'd just share mine with you because I thought it was really fun that they're doing this today. So I'm just going to go ahead and light my candles and show you what happens with mine. Oh, I've got my fan on above me. This is not good. I'm gonna have to Shut off my fan. Sorry. Okay. Let's stop it for a minute. All right, so I know this is taking up time, so I'll hurry as fast as I can here. I'm gonna back up so you guys can see it. All right. So I'm just gonna set it on the counter here. You can see it back here. And watch. It's centered. It's not centered on its end. There we go. All right, can you see it spinning? Isn't that cool? So these are hand carved little things. This is something in Germany that they have. They're very special to them. I hand carried it on the buses and on the planes all through my trip in Europe because I didn't want it in my suitcase. So for 2 weeks I would carry it in my bag and put it up in the buses when we were traveling from country to country all through France and Germany and Amsterdam. Okay. Okay. All right, pretty cool, huh? Okay, so we'll go back to the video here. And of course his is just doing the same thing. It's just his is homemade instead of
In the activity, you created a heat spinner that transforms heat into movement. Your spinner started moving when you held it over something hot, like a light bulb in a lamp or a cup of hot water or a heat pack. Maybe you noticed your spinner didn't spin as much when you held it beside the heat source or below the heat source. Why is that? Well, you probably know that hot air rises. This is also why hot air balloons float. There's a source of heat inside the balloon, and that heat rises. You know, in a way, you can think of your heat spinner as a kind of chain reaction machine. Something hot, like this light bulb, makes the air nearby it hot. As that hot air rises, it pushes on the spinner. Then the spinner moves. Take a look at Hero's toy again, but now consider it in the same way, like a chain reaction machine. Step 1. Fire heats up water inside the device. Step 2, water starts to boil and turns into steam. The air and steam inside are super hot. Step 3, that super hot air and steam rush out of the device through the pipes on either side, and that makes it move. At each step, energy is transferred from one part to the next, from the fire to the air and water to the container. The device starts with a source of heat and ends up with movement. Heat can cause things to start moving. So heat is yet another form of energy. Today, scientists have a special name for any device that turns heat energy into movement. They call it a heat engine. Hero's device is known as Hero's engine. Hero may have built it just for fun, but over 2,000 years later, it inspired inventors to develop a heat engine that was even more useful. The steam engine. This video shows a miniature version of a steam engine someone created out of glass, so that you can see what's going on inside. It does the same basic thing as Hero's engine. First, a flame is lit under a container of water, which starts to boil. Heat makes steam and air rise and move through the tubes. Then the steam pushes on a piece in here back and forth, which pushes on a rod that's connected to the wheel. Each time this container fills up and releases steam, it turns the wheel. Check it out. By attaching steam engines to the wheels on trains, the steam locomotive, or modern train, was born. This meant, for the first time ever, people could travel across an entire continent using machines instead of on foot or being pulled by horses. Using a steam engine, a trip from one side of North America to the other, a trip that used to take 6 months, now could be completed in only 4 days. And you know that's not the end of the story. Travel has only continued to get faster and cheaper, with modern forms of transportation like cars and airplanes. For example, on a train, it takes about 4 days to travel from San Francisco to New York City, but now you can fly that same distance in just 5 hours. The engines inside of cars and airplanes use other fuels instead of steam power, but they still run on the same basic idea that Hero's engine did, the heat engine. They use heat energy from burning fuel to make things move. We'll talk more about modern fuels and energy in the next mystery. Until then, have fun and stay curious.
Okay, so that's just a really cool mystery today, isn't it? So hopefully you had fun with that. Like I said, the other links are going to show you how a steam engine works, and that will be in your materials list. There'll be a link for that, and there'll be a link also for the engine in a steam engine, and then you can read that article if you want to go to that link too. Those will be in your materials link in the sheet that your parents get, that you guys get with your supplies list. So hopefully you have a great week. Enjoy the science. I'm glad that I get to see you guys on Zoom now. It's going to be fun, and we'll see you next time.